And welcome to the Daily Space Weather. Starting things out looking at the sun at 193 angstroms. We saw a C-class solar flare come out of this former sunspot 2816, this active region right here. Coronal mass ejection unfolding as we speak. And lots more to cover. Lots more to cover today. Let's get to it. Here's a colorized magnetogram and 171 angstroms composite here from the SDO. And the coronal mass ejection that we see is likely to be missing Earth to the northwest, although it is still unfolding, and we see an additional coronal mass ejection coming out of the southern hemisphere. So this one's happening as we make the video, and it's too early to get any trajectories on that. Here's another full disk view in 94 angstroms, one of the many ionized UV emission spectral wavelengths of ionized iron. Great view there of that C-class flare from former sunspot 2816. Here's where stuff is in the solar system. And there's where things will be in a week. Here's a star chart. And we've drawn in the yellow line here. That's the ecliptic. The sun will be traveling across Aquarius and Capricorn and Sagittarius and Ophiuchus and Libra and Scorpius throughout the day. Today, if you're up before dawn, you may see Saturn and Jupiter ahead of the sun. The radio flux of the 10.7 centimeter variety, which is a 2,800 megahertz frequency, which emanates from the upper chromosphere and lower corona, is at 79 solar flux units. Here's a one-year chart to put that into context. And you can find that yourself at solon.info. The red line on the bottom here is a sunspot number, and you can see that stat climbing here. We didn't see the KP index get as high as forecasted by NOAA here. We did see a KP of 5, and the coronal mass ejection is currently striking. We'll get to it in a minute. So we did see a brief period of geomagnetic storm conditions early in the day. So here's the visualization forecast model. And it's too early for the rest of the trajectory of the ongoing coronal mass ejection to be calculated. We'll probably produce another video later in the day on that. No major earthquakes over the past 24, although there was a 5.6 southeast of Saudi Arabia. We'll get to it. Small deep quake struck El Salvador at a 4.1 magnitude and over 100 kilometers depth. So here's the largest of the past 24 in terms of quakes. It's this 5.6 in the Owen fracture zone. Pay attention to the time and date stamps, folks. So a 5.6 was the largest that we saw in the past 24 here. A couple of deep quakes, but basically a lull in earthquake activity, more or less. We did also see a very shallow quake under Mauna Loa at over 10,000 feet of altitude. This negative 3.7 kilometer depth quake was only a 2.6 magnitude, but occurred at a depth of 3,600 meters above sea level, underneath the western slopes of Mauna Loa. Not too far from the surface there, actually. That likely magnetic or ground-settling quake, 2.6 magnitude at 3,700 meters above sea level, folks. And just to continue up the list here, again, no major quakes. There was a 5.0 at Indonesia, as well as a deep quake at Indonesia. That was a 4.5 at 128 kilometers. Also a 4.5 deep quake near Saipan at over 520 kilometers depth. Next volcanoes of the past 24 include Suminosejima, still exploding, still producing a 6,000-foot plume of ash. Sinabung, 12,000-foot ash plume. Semaru, 14,000-foot ash plume. Dakono, flight level 070, it's a 7,000-foot ash plume. Samisa-Pochnoi in the Aleutian Islands, now back to exploding, producing a 10,000-foot ash plume. Popocatépetl, 18,500-foot ash plume in central Mexico as it explodes. Fuego in Guatemala exploding, 16,000-foot ash plume. Sangay exploding in Ecuador, 19,000-foot ash plume. Revenador exploding in Ecuador, 15,000-foot ash plume there. And Sabancaya exploding, 27,000-foot ash plume in Peru. Please don't pole vault the caldera. This public service message brought to you at great personal risk and expense by smAsho.com. Welcome to the Neo Renaissance. Visit our website, smAsho.com, smAsho.org. Visit our social media links. Tell us your favorite social media in the comments. Don't forget to click smAsho merch and pick up some merch, such as this ultra high quality shirt. Do Not Pole Vault the Caldera in Volcanic Ash Gray. Our premium Do Not Pole Vault the Caldera t-shirt. Again, you can find the link at smAsho.com. That's smAsho merch. Getting back to solar data, let's take a look at the X-ray flux, shall we? Do you want to know what's going on with the X-ray flux? Well, here it is. And again, this C-class flare, the largest of the past 24 hours, happened at about 1:40. More like 1:30. And we'll talk more about that on the next frame. The deabsorption region, yes. So the ionosphere has a tendency to absorb radio signals as opposed to re-emitting them. So this is that solar flare in terms of its effect on the ionosphere. And the D layer, which is 2 layers below the F layer that we show daily on the daily space weather videos, gets affected by this as the material in the ionosphere absorbs and re-emits radio signals. Sometimes you get a hole in the D layer. Essentially, a radio blackout is caused this time in the central Pacific Ocean, rather. It's the deabsorption region, the DRAP. And that's the 1 decibel absorption, and I don't want to spend too much time on that. That is one of the direct effects from solar flares. More on that later in the video. And you can bring this up yourself. This is one of the many Space Weather Prediction Center links you can find on all of these pages. The deabsorption region. We don't see any strikes in the proton flux. No surprises there, as no major proton events have made it to the GOES 16. No surprises there. We forecasted it. Here's the GOES magnetometer over the past 3 days, and you see these big spikes. Part of that is the arrival of the coronal mass ejection. 3 days of GOES magnetometer. These arcjet moments, by the way, are when the GOES 16 operates its thrusters, which create plasma and can affect its measurement capacity. And for you new viewers, the N's and M's mean midnight and noon time. Noon and midnight for the GOES 16. Here's the top view ecliptic plane field plot showing you the heliospheric current sheet and its polarity. Earth is now solidly in a North Pole current sheet. And we're expecting to remain there. Keep in mind the data as presented here is 1 hour and 14 minutes old. And remember to look at the time and date stamps. Here is the line of sight ecliptic plane field plot. It's a 3-dimensional line of sight view of essentially the same thing. And you can see the North Pole current sheet shown here in green, South Pole shown in red. Here's the line of sight coronal hole plot, which also shows you the sun's B field in blue. And we do see some movement in the sun's B field as cycle 25 takes its good old time to progress. And it looks like the North Pole-oriented coronal hole has largely evaporated here. There's the latest image. It was transequatorial a few days ago, and now it's only reaching down to a few degrees of latitude. So that little spot there, that little spot of green right there, it's a coronal hole which has receded in the past couple days. So here's a view of the detected filaments, the magnetogram and sunspot groups. Sunspot 2818 has remained fairly stable over the past 24 hours. Again, the likelihood of additional coronal mass ejection remains at nearly 100%. In fact, there's one propagating as we make the video. Lots of filaments down here still attached. Some are detaching as we speak. KP index made it up to 5, as we said earlier in the video. The KP index is a measurement of global geomagnetism, if you're wondering what that means. And it looks like the coronal mass ejection impact is already subsiding. Next, the real-time solar wind should show us the subsiding of the coronal mass ejection impact. So the solar wind speed only made it up to not even 500 kilometers per second from that, and the density made it up to about 15.5 protons per cubic centimeter. That has since waned, and I would note that you also see a change in the plasma temperature, the phi angle, and the BT/BZ all at the same time. That's a signature of a coronal mass ejection, folks. Current conditions of the solar wind are about 9 protons per cubic centimeter for the density and about 478 kilometers per second for the speed. Here's the geospace over the past 4 hours, and we can expect to see the pressure drop a little bit here as, again, the coronal mass ejection impact has subsided a little. It's 4 hours of data courtesy University of Michigan. We show it daily as the data is not yet visible in archival format. Some oddities in the shape of the pressure here. Next, looking at ground magnetic perturbations, we're going to also show you the polar view. First, the global view. Delta B in the geospace means changes to the Earth's B field. So earlier in the video we showed you the sun's B field. Now we're showing you the ground magnetic perturbations in the Earth's B field. And they are related in some ways, folks, although mainly through the impact of incoming solar wind particles, solar protons. They produce Bremsstrahlung, otherwise known as the braking radiation, when they're forced to decelerate and make up their mind and join a field-aligned current or be sent back into the solar wind. Here's the polar view, and let's bring this back to show the full 4 hours of data here. And since the Earth currently has 2 north poles, one over Siberia, which is the stronger one, and one over Canada, which is the weaker one, we're wondering if there may be 2 south poles, as the south geomagnetic pole has crept into the southern Indian Ocean south of Australia, thousands of miles from the south geographic pole. Next, I would like to welcome back our Twitch viewers. Welcome back, Twitch viewers. Cheers. Thanks for tuning in. And I would remind you to check out our bitchute.com/smAsho page as well. The official BitChute page of the Smash News Network, least busted name in news. There's exclusive content there, such as our video about hydroxychloroquine. And twitch.tv/smAsho is a fantastic live streaming platform. It's why we use it on the regs. Thanks to our new subscribers over on YouTube. Don't forget to press like, subscribe, share, etc. Tell your friends, foes, science noobs, and science pros about the channel, if you would be so kind. And this is our cosmology segment. So today's cosmology segment should be interesting as always. And let's get to it. First in today's cosmology segment is the NASA astronomy picture of the day, which is of the Ant Nebula. A nebula which looks a bit like the ant, like an ant. So, and this is believed to have a sun-like star at the middle. It may be a binary, but it's not fully understood how this nebula was created. So perhaps this gives some insight into the evolution of a star like the sun. And I would remind our viewers that all stars are variable stars. All stars appear to be able to create all sorts of heavy elements without becoming supernovae and exploding as they do it on their surface. It's something we observe. And the Ant Nebula has what is believed to be a planetary nebula surrounding it. So it's quite a busy area there. And you can read more about the Ant Nebula. It's quite a famous nebula. Does it give us insight into the, quote, death, and quote, of our sun? I don't think so, as I'm not necessarily convinced that stars are born or die, as it's something never observed. Let's pick a random object on the Neil Gorell Swift Bat X-ray Observatory. I've already done so in show prep today, and today's random object coincides with number 833 at the Neil Gorell Swift Bat X-ray Observatory, which is Scutus X1. So here's an interesting paper about Scutus X1, dating all the way back to December 1967. And this is an odd pulsar in that it is a Doppler shift-induced radiation pulsar, perhaps. And we're not exactly sure how it works, but this paper from 1967 was proposing some legitimate ideas about the production of all of the different spectra coming out of it. So it's obviously an X-ray emitter. It's also a radio emission source. So perhaps check out this paper entitled "The Doppler Effect as the Cause of the Splitting in Type II Radio Burst Spectra" from Scutus X1. So here's Scutus X1 in infrared. This is the 2 mass, and it's at a pretty busy part of space, folks, which is why you won't be able to see it in all sorts of different wavelengths. You can see how many objects are located in that part of the sky. It's quite close to the galactic plane, as you can see here. That's the Milky Way there, folks. And we'll zoom way in here. There again is Scutus X1 in infrared light. Let's see if it shows up in any other wavelengths. Here it is on the multi-mirror project. That is X-rays from the XMM Newton. And let's see if it shows up in blue light. Nothing there in blue light. How about in UV? And it's not emitting in UV. Let's close out the views of Scutus X1, the irregular and odd pulsar radio and X-ray emission source. Scutus X1, today's random object. Let's talk about a new Octo-Tiger astrophysics code model. It's just a model, folks, and it's a model designed to create a high-resolution animation, a model of 2 white dwarfs in close rotational proximity. Here's a little run of that for you. And I would note that the red arrows indicate stellar winds of over 1,000 kilometers per second. The blue arrows indicate slow stellar winds of 1 kilometer per second. It's the Octo-Tiger simulation model. Is it good? Is it legit? I don't know. I have no idea. But it's an article here on SciTech Daily, "The Breakthrough Astrophysics Code, Rapidly Modeling Stellar Collisions." And that's today's cosmology segment. We'll have to say goodbye to Twitch. Bye, Twitch. But we'll bring you back for today's meteorology segment, which should be interesting, as always. And let's continue on with the daily space weather videos. We're going to go to the realm of electron flux. So we've seen a little dip in the electron flux here. Here's the 1-year chart as reported by Solon.info. The greater than 2 mega electron volt electron fluence over the past year. And we saw this dip down right as the coronal mass ejection struck, as there are a little bit of a surplus of protons up there. And solar protons really want an electron, which is part of the reason why we see these dips in electron flux when those protons arrive in the solar wind. It's a signature of coronal hole wind streams as well as coronal mass ejections. So we don't see significant charging hazards here. Charging hazards are pretty minor. Let me press refresh. So we see some minor charging hazards here over Mexico and Central America. Not a big deal. Here's the forecast model for electron flux, and NOAA's forecasting a leveling off and then a dip in the electron flux. The forecast model here is the green box. The yellow diamonds are the observation. Here's a diagram of the Van Allen belts. Feel free to pause the video if you like. And here's a visualization of the total electron content forecast. This will show you the likely spots for GPS errors here on planet Earth. And please leave us a comment if you're viewing from another planet, solar system, galaxy, plane of existence, time frame, universe, multiverse, etc. Let's talk about the effect of solar flares on the magnetosphere. Now, we talked earlier about the deabsorption region. And the deabsorption region is where radio signals go to die as they get transmitted into space instead of being re-emitted to Earth. We covered this article yesterday. It's worth taking a moment to revisit this one. The effects of solar flares on Earth's magnetosphere. It's in the phys.org Astronomy and Space section. I'm going to let the article scroll here. Again, feel free to pause the video. It's the beauty of video on demand. You can pause it, and we'll be here when you return. Feel free to have a read on that one, the effects. And now our next pane is a diagram of the atmosphere. We're showing you this because most of the X-rays from the local yellow dwarf are adsorbed. That's with a D, adsorbed, by the time they reach the mesosphere. So the deabsorption region is this one right here, folks. That's the D-ionosphere layer. So when we showed that deabsorption region caused by X-ray flares, solar flares from the sun, that is the location where they are causing an effect on radio signals. I would also note this F. It's the F-ionosphere layer located at about 300 kilometers of altitude. The D layer is located more like 100 kilometers of altitude. Here's a visualization of the F-ionosphere layer. So each little tick of this represents 15 minutes, folks. We show it daily. This is courtesy of Australian Government Bureau of Meteorology. And the ionosphere is looking fairly normal here so far. No significant anomalies. Keep in mind that it's only showing you 1 megahertz of resolution here. Each blob represents a difference of 1 million vibrations per second frequency, otherwise known as megahertz. So here's the latest image from 10:45 Universal Time. Everything looking fairly normal there. Let's talk about Earth rotation once again. We've been bringing it up regularly as some, quote, competing, end quote, channels who do the, quote, same thing that we do, end quote, don't seem to understand Earth's rotation. When Earth rotation speeds up, folks, it is a sign of global cooling or some issue with the water. Now, I don't personally believe that the Earth's outer core is comprised of liquid iron, but let's just leave that all aside. Guess what this article's talking about? This article is talking about how Earth's rotation is affected by surface water and underground water. So this is blaming humans for pumping water and for sequestering water through dam projects. And while that can affect the Earth's rotation, I don't believe that it is. But in any case, certainly what affects the Earth's rotation is the Equatorial Bulge. So I'm going to let this article scroll here. This is a SciTechDaily.com article. Feel free to have a read on this one. This is from a Chinese source, I believe, and it's actually blaming the polar shift on the location of water. And this is a fairly reasonable explanation, as water emits radiation, and it affects the ionization pathways. So let me just take a moment to draw on this little animation that we've got here. And since this is actually related to meteorology, let's welcome back Twitch. So we've gone live to Twitch to explain the Equatorial Bulge. So here's the Earth in rotating form, and Earth is oblong in that the water around the equator bulges out. This is what causes the Earth's tides. So as the Earth rotates, the water at the equator bulges out, and the sloshing back and forth of that water as the Earth rotates is what causes the tides. If this equatorial bulge shrinks, if it's only this big instead of this big, that causes the Earth's rotation to speed up, the same way a ballerina speeds up if she's spinning around and she pulls in her arms. The Earth speeds up when less water is located at the equator. So cold water takes up less space. So if the oceans cool, or if the oceans shrink as a result of more water being deposited near the poles as a result of snow and ice, or a combination of those two things, it would be logical that when you get a colder ocean, you get more water in the form of snow and ice being deposited near the poles where it's colder on the planet. That would cause the Earth's rotation to speed up. So this article from SciTech Daily talks about this, and once again, it's no fun being right all the time, but this is blaming mankind for changing the location of water on the planet. Keep in mind, folks, water emits radiation. Water changes the ionization pathways of the planet. And this article is even blaming the geomagnetic pole shift on the location of water on the planet. So perhaps have a read on that from SciTech Daily. A great article here about the Earth's rotation being affected by the location of water on the planet. So let's continue on, since we're talking about some climate stuff. Here are the surface winds of the eastern world. And let's move this to the 250 hectopascal winds to show you the location of the jet streams. There are the jet streams. It's the 250 hectopascal winds of the eastern world. Massive anticyclone here over the central Pacific. That clockwise rotation associated with high pressure, undoubtedly. Here are the jet streams of the western world. And we'll show you surface winds here as well, as we've got an anticyclone off the coast of... Sorry, that's not an anticyclone. That's a low pressure. My mistake. It's a counterclockwise rotation, a low pressure off the coast of Portugal. And shout out to our Portuguese viewers. And our viewers who aren't Portuguese but are viewing from Portugal. Cheers. Here are the surface winds. And we see some strong winds off the east coast of the U.S., perhaps creating some good surf. We're hoping those are offshore winds to provide the largest waves for our East Coast surfing pals. Next, we'll take a look at the real-time lightning maps at lightningmaps.org. It's where I go when I hear thunder. Lightningmaps.org. My real-time lightning map source. It's powered by blitzortung.org, if you're wondering. And we don't see any terrestrial lightning. Actually, we do. Check it out in just off the Palm Coast here. Flagler Beach, hey Daytona Beach. Go out and look to your northeast. There's an active cell up there. Take some time-lapse photography. Maybe you'll get some imagery of sprites. And we covered some severe lightning yesterday. And I don't know why we're on OpenStreetMap, but we are. Allow me to close OpenStreetMap. And we've got some stories on AccuWeather, such as this shocking dash cam footage. Check out this car crash. This is a deadly 48 vehicle pile up here, located in Wisconsin. This is not what you want to see through your windshield, folks. So he's just following this truck. There's a vehicle pulled over, and there's a jackknife truck. And here's bad times for all involved, if it loads. Come on, AccuWeather. You can do it. And it looks like the vehicle that we're in is sliding around, and it's regained control, and there goes that truck out of control, and ouch. And yeah, there goes a snowplow flipping over. And apparently in Wisconsin, it's so hot that it's cold. Sorry about all that global warming, folks. It appears to be, by the way, there are also tornadoes, and the southeast saw damaging hail yesterday, and we covered it very early in the morning. Our patrons would know all about it, and you would too if you were a patron. So maybe consider becoming one at patreon.com/smAsho. Here's pressure cells as reported by windy.com. And we're going to advance this via the GFS forecast till tomorrow. Here's the forecast for GFS. The GFS forecast for tomorrow at noon Eastern Time, Eastern Daylight Time at noon. There are where pressure cells are expected to be by the GFS forecast. Here's the Euro forecast, if you were wondering. Not all that different. Euro forecast, GFS forecast, and continuing on. Here's the U.S. Doppler radar map. We'll also show you the cloud layer. And here's the water vapor. And it looks like things are clearing up here. That string of storms expected to migrate slightly to the south as it slowly moves offshore here from Florida, being propelled by dry air trailing it. And that's today's meteorology segment. Thanks for tuning in, Twitch. Here come bonus features for the rest of you daily space weather viewers. Bonus features will be in the form of the most recent imagery from the El Teide, Spain Solar Observatory, part of the National Sunspot Observatory. Let's play the animation. You can see massive filaments still down here in the southern portion of the sun. You can see one of the filaments up here disappearing as it's in the process of ejecting right now. So lots of stuff going on, folks. Again, we'll probably be making another video later today. Thanks for tuning in, SMASH team. Thanks to the most important members of the SMASH team, our patrons, the true source of funding for the content. Thanks, patrons. Please consider becoming a patron at patreon.com/smashomash. And by the way, if you'd like to win a free month of Patreon for May, time is running out as the contest ends at midnight on the last day of April. Head to smashomash.com/forum. We've pinned our April Slam Poetry Contest into all of the forum threads. So whether you view the cosmology forum, Earth and geophysics, heliophysics, the sun, general science, etc., check out our poetry competition. You can win a free month of Patreon at our $3 per month tier level by simply winning our Slam Poetry Contest. Here comes some more bonus features. This is the solar magnetogram and the solar intensitygram. Here's Sunspot 2818, which is quite complex, and it's been growing additional umbrae over the past day. Here's the colorized magnetogram of it. Magnetogram, intensitygram. It's got two more umbra that have formed in front of it now, so those are new, and the likelihood of significant coronal mass ejections and solar flares has gone up as one propagates as we speak. We're going to close things out with some additional views of this particular star, my personal favorite. And so there's that. And how about some more close-ups of Sunspot 2818? Here it is in 94 angstroms. And you can see those new additional umbrae forming underneath the Earth scale region there. So a significant uptick here in the total umbral area of Sunspot 2818 as it moves into the Earth-facing quiet effect zone. And last but not least, here is that same area in 171 angstroms, my favorite wavelength. Thanks for tuning into the Daily Space Weather, folks. Remember to share the content in your social media. Tell your friends and foes. Tell other YouTube channels. We'd be more than happy to interview them. Just drop us a line. You can find all of our contact information and social media links at smashomash.com. We'll see you next time at the Daily Space Weather. Welcome to the Neo Renaissance, and may that solar wind be at your back. And thanks for tuning in to Smash News Network, least busted name in news.